All right. So basically, what we're going to do on this stream, or what we're going to try to start doing, as I stutter, it's like the editor has to do it. What we're going to start doing on this is we're going to run a single variable calculus class and a multivariable calculus class in the classic way that most academic institutes do this, or universities, colleges, etc. They're going to break it into 3 or 4 classes. Classically, from where I come from, Edmonton, Alberta, Canada, we have the University of Alberta, Concordia University, MacEwan University, and NAIT. Their versions of this is going to be broken into, for engineers, 3 classes: Math 100, Math 101, and Math 209. What that means is single variable calculus 1, single variable calculus 2, and multivariable calculus. For the regular stream, they took the Stewart calculus book in the 90s and chopped it into 4 and didn't really think the curriculum through at all, from my point of view, and just went, calculus 1 is these chapters, calculus 2 is these chapters, calculus 3 is single variable is these chapters, which is single variable. Then it starts to 214 starts to turn into multivariable calculus, and weird things at the end, which I'm changing, and then 215, which would be a multivariable calculus class. What we're going to do is calculus, we're going to do like the engineers, but we're actually not going to start putting in PDEs and multivariable calculus at the end of this. We're going to do a single variable calculus 1, which will introduce you to real numbers, functions of real numbers, the limits of real numbers, and then I use limits of real functions of real numbers to define systematically the definition of what a derivative at a point is for a function, and what a Riemann sum or an antiderivative is, and then we'll go into those games. Calculus 2 will get into more depth of more functions possibly, and the second single variable calculus class will do is get us into more functions, transcendental functions possibly. I don't know exactly how I'm going to map this out. You'll get most of them in the first class anyways. And then you need a few more sophisticated techniques in here for taking the antiderivative. Antiderivatives are much harder than derivatives. So the second calculus class will be mostly techniques of integrations and the applications of integration. And then the multivariable calculus class will start with all these three-dimensional. You have to start going from when I see x squared plus y squared equals 1, or in the first one, x plus 1 equals 0, or something like this. We can make it minus, so it's nice. What we're doing is you view this as in 1 dimension, probably in your brain, and then eventually you start seeing these, and then this one's in R2. It's a circle in the plane, and then what you have to start doing is x squared plus y squared equals 1. You're like, what? Your brain has to, you're like, you just wrote down the same thing, but yes, in here it's going to be a circle. But in here, what we're now doing is, that's the circle in the plane, but then it'll be dash, 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 because z can be anything. And so this equation in R3 has to be, but your brain is so used to doing this or this, that when we talk about points, we're not talking about a single point. This is a point, this is also a point, and then this is a point. And then if these are points on graphs of functions of more than one variable, you have to start thinking in 3 dimensions. So we'll start out with retraining you how to do that, and then they have the classic conic sections instead of the circle, the parabola, the ellipse, and the hyperbola, the ips and the ellipse. The ips is a little bit different than the ellipse. He doesn't play nicely. But then you can get the ellipsoid, the paraboloid, and all the hyperboloid of 1 sheet and 2 sheets, and then whichever one I missed, spheres. So then we'll start with that, then Lagrange multipliers, etc. Lagrange multipliers, by the way, I was looking at a different calculus book, not Stewart calculus, and there's like, that book has like 6 or 7 different ways of optimizing and finding max bins, and Lagrange multipliers is probably the best way, but I'm going to probably show 1 or 2 more just for shits and giggles. We're going to show 1 or 2 different ways of optimizing beyond Lagrange multipliers, and then we'll go from there. All right, so what we're going to do is, in the first Calculus 1 class, we'll break it into 2 playlists probably. I don't know exactly how it's going to go. First, we're going to tell the story appropriately, the way that I want to see it. What we're going to do is, in the overview, as we start, chapter 1 will be the real numbers and beyond. There's other types of numbers which start to become multidimensional, the complex numbers, the Hamiltonian numbers, or quaternionics, etc. You're like, I don't want to know this. It's like complex numbers come up real fast, real quick, as soon as you want to solve an eigenvalue problem of a rotation through 90 degrees or something, and then you get this equation, and those are your eigenvalues. All of a sudden you get plus or minus I. which is plus or minus the square root of -1. So already the beyond starts to become, well, why can't I quickly talk about this just because we're not going to use them in this class? You probably will, and depending on how you've been watered down, eventually when you water down vodka too much, you're drinking water. So we want to drink straight vodka, 150 proof, let's go. And then you're like, why would I want the four-dimensional numbers? Well, once you have I, and then you have J, and then you have K, and then 1, these four generators will create a four-dimensional object called the quaternionics. And these numbers put in 2x2 matrices are what you use for rotations in Call of Duty. So anyone who likes caught, oh, I gotcha. So I'll just point these things out quickly, just like I am in a few sentences. And then you have the real numbers and beyond. So chapter 1 will be the real numbers, the types of numbers that we get from commerce and sharing and those types of things. And then what the intuitive, not using the complete red pill. Sorry, Sean. Sorry, Sean. I said sorry. Sorry, Sean. We're gonna do a in between. Is there a green pill? Because there's your red and your blue are so extreme. Can I just take a green pill that's halfway where I can just understand what the fuck is going on and carry on with my life? Yes, we're gonna green pill, bitches. I'm just coining it right now. There's no black pill. Green pill. Positivity. Go and find out how science works. What we're gonna do with that is we're gonna do the rough types of numbers, and then we want to do functions of real numbers. And so the way that I'm going to do this intuitively, instead of using Cauchy sequences or the congruence classes of all Cauchy sequences, and then we say two numbers are congruent in that Cauchy sequence set if they're, or two Cauchy sequences are equivalent if they converge to the same real number or to the same value, etc., etc. I know how Sean wants to set this up. My cameraman just got subjected to the red pill version of this. I'm going to do the green pill where I back it up. And what I'm going to cleverly do is, the fastest way to do this is show you that every real number, whatever that set is, has a decimal expansion, base b larger than 2, but we'll stick to 10. And then because every number now has a decimal expansion, that decimal expansion can be either infinite non-repeating or infinite repeating. If you're infinite non-repeating, you're what we call irrational. If you're infinite repeating, we call you rational. Every real number has to have either a repeating part or a non-repeating part, and no number can have both a repeating and a non-repeating decimal expansion. Therefore, the real numbers are the disjoint union of the rationals and the irrationals. This is what we're going to build in the next few hours. Let's go. And cut. Why am I highlighting these ones? Because what Sir Isaac Newton wanted was how things move, variation. And in Latin, it would have been the calculus. Well, it's in Latin, I don't know. Cogito ergo sum is the only fancy I can do this. I think, therefore I am. You guys could be fucking walking zombies, but I don't know. I can think, so I must exist. Is that modus ponens a priori? Rene Descartes? I digress. What he wanted was, he wanted to lob cannons at the French. And so he needed to know that that was an upside down parabola, and then you could find out trajectories for ballistics and stuff like this. And then the apple was a facade too. I don't think there was ever an apple, but he realized, I don't think people appreciate the foundation of what Sir Isaac Newton did in the Principia Mathematica also, which is fucking amazing. He took back then, in the 1600s and 1500s, up until then, they thought that there was mechanics that did celestial things, celestial and then terrestrial. And he thought with the cannon, if you got it to go fast enough, it would go into orbit. And then he realized that the planets are in these orbits. So then he took something and then he showed the mechanics of the celestial was exactly the same as the terrestrial. And he created the first mathematical description of gravity. He didn't know how it worked. Einstein showed that it was actually the space-time is being bent, and that's how you're just trying to go along a straight line with the forces. But he didn't know how it was working at the spooky action at a distance, different spooky action at a distance, gravity, spooky action at a distance. He didn't know how the sun knew how to talk to the earth, but he realized that that mechanics was the same thing as throwing cannons at the French. You can bleep, bleep, bleep. But what he wanted was how things move in space and how to describe that mathematically. And all they do is they did this to your course and called it calculus, and then all you're doing is computing a bunch of things inside there. They're not giving you the story of what's going on or any of these types of things, so let's start trying to do that. The calculus of variation. We need real numbers and more hands. We don't need you or you. We need you. Just hang on a second, you'll get your turn. He talks to the pen sometimes, I don't know. Are you? It's coffee. Am I sober? If coffee and beer and shots, trust me, watch. Yeah, your mind. It's the same as a guitar. Every time you drink a beer and a coffee, as you talk, your motor skills and your sharpness will go down by half. We used to jam with the Smalls and Pugnacious after in high school. We used to go after their gigs and stuff like that. We would go to the basement, fucking Jesse Zaraska's basement, and we fucking death metal. But the drunker you get, you have to tap out, and then someone else can have a turn on the guitar because, yeah, Jesse was the first one to say it. Every time I have a beer, like my coordination, I can't do fucking speed metal when I'm drinking. Or yeah, drugs and alcohol are not going to sharpen the skill of what you're doing. It's going to negate it. It doesn't mean we're going to do it, but as we're editing, we're going to get shit-faced, not while I'm up here. Is what you would say if you wanted to be drunk in front of the camera. All right. There's either way, there's still some motor skills, so I don't care. It doesn't matter. Oh. You guys can get the fuck out of here. You learned your own goddamn math. Mabel. All right. And action. I let him get one. I'll move him out of there before he starts going.
You've been on this whole time.
I know. That's what I'm saying. We can finally do videos the way we want. Mathematicians turn coffee into theorems. So let's just intuitively go. I didn't even write a script. We're not even going to do this. I just was like, what's our first video supposed to be? Numbers. Numbers. Colors. Roy G. Biv. You can thank Newton for that. Also, let's lean. What are the numbers? Types of numbers. I don't know how that... You can rewind that in reverse so that the numbers goes backwards and disappears. Edit it. He's yelling. There's no one. He's alone in the basement. There's no one else in the room even. What the fuck he's talking about? Types of numbers. And the first thing you need is all you young pups watching this. Hopefully it's young pups. That sounds wrong when you know, in context. But you want to access the minds of the young. You don't know, what's the three most important things when you buy real estate? What's real estate precious? A house where you're going to live so I can build a YouTube studio in the basement. Location, 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 they say. It's one thing. Repeat it 3 times. Where your business is or where your house is the most important thing. And so what's the most important thing in math? The jokes set themselves up every time I start talking about it. We're going to do notation. Notation. And I'll write it out and say it 3 times. Notation. Did I spell it the same 3 times? I had a homework assignment one time, tangent, pun intended, you'll see, that he handed in this thing about symmetry, and he said symmetry 5 times, and every 5 spellings of symmetry was wrong, and none of them was the correct spelling. So he had 5 alternate versions of symmetry, and every time he said symmetry, he spelled it a different way. I think I took a picture. It was amazing. I was like, this is fucking awesome. Not only did he spell it wrong, we spelled it wrong 5 different ways. Fucking, did he do the permutations? I think he might be fucking with me. Anyways, notation, notation, notation. So as I go, we're going to get these, instead of doing it brutal or the way that the book is going. By the way, there will be a PDF linked in the thing so that you can have the complete correct. I've done the textbook and done it the way that you're supposed to, so that in case I forget something or say something wrong, you can double check me and put it in the comments. Please comment, actually, it should have been a 7. You can do that. But we're just going to start going, and as I need them, as a monkey brain, I'm just going to be like, oh yeah, I should have talked about sets, and so we'll start doing that. So we want types of numbers, but we want to put them in baskets. And there's a bunch of different baskets. Baskets are going to be the sets. Numbers or elements are going to be the things I put in the baskets. And then we know notation for that. Big guys are sets. Little guys are the guys in there. And then I need a fancy E or one of the, that's a 3. We'll see. Well, 3 epsilon will do. Yeah, I just did one for, it's awfully symmetric in the thing. I could just reflect it. But can you symmetrically reflect an E so that it's an epsilon? It's all Greek to me. This is just on coffee. Wait till you see the amphetamines. All right. So what are the types of numbers? As we're going in circa 3100 BC, I'll give it back to them. The devil you know is better than the devil you don't, even if it's Jesus. So they like to put BCE, before Common Era, before Christ. 5,000 years ago, the Babylonians. Uh-oh. Me fail English, that's impossible. Plural, that's also in there. One Babylonian, many Babylonians. That'll be the distinction, which I'm about to get to. That was a pun intended, unintended. Fun intended, pun not. So 5,000 years ago, what we have is they had these little clay tablets, which were almost the same size as your frickin' phone. I've got wreck stuff. This is a Babylonian tablet called the Plinkton 322 tablet, and look at frickin' the size of what they were making them. 5,000 years later, we have the same type of handheld thing. It's just electronic, analog, digital. Yeah, me likey. He's like, I want to look at that now. Not only do I have that, I paid a guy in Etsy to get me a new one. So here's the version. And this one was made by this guy in 2017, and this one was made 5,000 years ago. Same type of thing. You can make them cuneiform. So what they realized was what they were taking tablets, and they would do this, and they would have cuneiform with the wedges, and they would create numbers. We'll start showing what they are, and then we'll have 5s and 10s. We can do this. But what they also had was, I completely forget what I was saying, so we can edit it in there. We are going to have, what they also had was these little pouches. And so when you owed money, commerce starts driving the first negative numbers and the first integers. Before we get to negative numbers, let's do the positive numbers. So they'd have a little pouch, and you owed you took 7 bags of grain, but you haven't worked it off yet. So then what they would do is they had these little, they were little clay wedges. I guess they would be wedges, pyramids. It's okay, it's okay. And they would put them inside there, and then they would keep that, and then when you 6 months later did it, they would say, okay, you've wiped your debt and you worked enough, and that you owed us 7, and they would know, and they would keep track. But then they would have to crack these open, or they would get wrecked and stuff. So what they would start doing was using the cuneiform to say there's a 5 and then 7. I said upside down triangle. 7. So then they put the 7 in there, but then they would mark on the outside. And then some wizard came along and was like, oh, some Babylonian wizard was like, I don't even need to put the 7 clay things in there. I don't need the actual physical widgets anymore. I can just put the number, and then they get the abstraction from this, from the number. So instead of having the actual physical pebbles, say, for simplicity of me drawing them, then they could just say, oh, I could use the first version of that would have been a 3. And they're like, there's the cuneiform version. I'm pretty sure that is. They were using the stylus, also a stylus, to wedge them, and they had 2 different shapes. Whether you use the full on or the side of it gave you the 2 symbols that they're going to use for 5s and 1s. You would use it even when you were counting as a kid, the days. I just did another 4 days without using math. No, you're dummy. You had to use the symbol to index the number. If I just did another 5 days, so you didn't see how it made a new symbol. First, it was just 1, and there's another 1, another 1, another 1. No. This is a 5 now. In Roman, it became V. And then they kept going, decim, centum, etc. So what they realized was, and then what does that become for us? That was also 5s, not a 3. So I should have used 3, sorry. And then what do we get? There's the Sanskrit or the Hindu Arabic version of these things. And what would it be? I don't know if it's true or not. But 1, 2, 3, that was 4, 3. So then with the point being is we get an abstraction from where are we even getting numbers? And this is the epiphany to where are these things actually in the universe? The pebbles, here they are. There's 3 pens. But now, whether it's 3 pens or 3 birds or 3 people, the abstraction is 3. And this is the mind Big Bang explosion, the first one that we needed. There are still some indigenous tribes that don't have the concept of number. They can only name their grandkids, but they don't know that they have 7 grandkids. They just have 1 and many. The Babylonian or the Babylonians, it's still in our language. So the first abstraction 3,100 years ago is that we would get the abstraction from the quantity of anything to the threeness of each of those things. It didn't matter whether it was, Lorenzo, you do 1/2 of the tree like this, then like this. So 3 trees, 3 pebbles, it didn't matter. This is what the Romans, yeah, that's what they're going to call it. It doesn't, how do you add that plus this? And then that guy becomes actually this. But then that has more strings and he's less. That starts to cause a single digit now becomes more than our magnitude. If you give 3 3 3s, that's clearly got to be more than the longer it becomes. We're going to get into that too, but the longer it comes, you can tell the magnitude of the number just based on how many digits he has. So this is the idea. The long story short, that's medium. The green story short is that up to 5,000 years ago, we get the epiphany of saying we don't need to know whether it was 3 trees or 3 pebbles or 3 things I owe. We're going to call it this guy. Mine's going to look like that most of the time. 3. This is called the Hindu-Arabic numerical system. This is from, I like to throw the swagger out there because the white guy can go, and so it's Muhammad ibn Musa al-Khwarizmi comes up with this in about 600 AD. Many, many years after this, it took us before we get the abstraction from the symbolization to what we call base 10 Hindu-Arabic. Name 2 countries arbitrarily in the world. Do they speak the same language? Probably not. Are they using base 10? Yeah. We consolidated math. If the rest of politics in the world could consolidate like math has, their mathematics knows no boundary. None. So now that we have this idea, the epiphany of number, what we start doing is, and then now I can't remember, it was circa 2100, I think, BC. We start getting the different types of numbers in commerce and these types of things. So quickly, as the overview, in the next video, what we're going to do is we're going to get the types of numbers. We're going to get sets is the mathematical thing we need, and then we need operations on sets is the other thing we're going to do in compartmental, and then we're going to talk about elements in sets. And the one thing we do is quickly, lowercase means that, let's use an X and an A. Lowercase means that this is a multiplication, that's an X. There's a difference subtly. This, we're going to get this fancy E guy, and then we're going to say an A. And then we want to talk about sets of real numbers. So the big guy that we're going to eventually get is this guy, R, which is the real numbers. In interval notation, which we'll also go through, is negative infinity to infinity. Open bracket means you can't ever be this guy. This guy is the abstract quantity, which is larger than every real number. Think of a real number, he's bigger. Think of a small number, he's smaller. That's what the reals are going to be. So we need sets. We need to talk about sets and then things in sets. Then what we're going to do is list these numbers in chronological order from our species finding them. I should probably do it the way Sean does it. Okay, I will. Based on the Peano axioms, or what a positive number is, zero's not in there. So the natural numbers, you're welcome, Sean, is 1, 2, 3. Axiomatically, the natural numbers have 0 in there because we call 0 the empty set. And then 1 is the set with the empty set in it. And then 2 is the set with the empty set and the set with the empty set in it. And I'm not going to draw, it gets fucking out of hand real fast. But axiomatically, using the Zermelo-Fomenko 13 axioms, the 13th one is the continuum hypothesis, we'll talk about this later, is we need this type of thing. So quickly before we go, we're going to use these, and hopefully I can draw a left and a right one fairly consistently. Squirrely, squiggly, squirrely bracket, left bracket, right bracket. Those are going to say there's the basket. I've got 3 pebbles and I want to put them into a basket. So there you go. There's our basket of numbers. And what that just means is, without that symbolization, we just say the naturals are going to be 1, 2, 3 ellipsis. And so we just wanted a basket notation, which we'll describe in the next video for the set builder notation and what the baskets are. And then chronologically, what we're going to get is we're going to get die ganze Zahlen liebe Gott gemacht, alles andere ist Menschenwerk. God created the integers, the rest is the work of man. And I'm not changing it. It's a direct quote from Leibniz. Leibniz? Some smart dude. There will be the editor will put who actually did it. I'm pretty sure it wasn't Leibniz. It was frickin' the Germans. I can't remember his name now. Damn it. Kronecker. Kronecker said this. I don't need the internet. I've got it in here. So the next one we're going to do is die Zahlen. Z is for Zahlen. In German is number. Die ganze Zahlen. Liebe Gott gemacht. A beautiful God made. And so the Germans are going to come up with my coding theory a little bit. The Huns and the Visigoths, and then, yeah, the Germans. They keep cropping up every couple thousand years. This guy in our notation is going to be, without using set builder no too fancy, now we need, first what we add is the epiphany in the Hindus, get it? Aryabhata. It is Aryabhatia, I believe, and Brahmagupta. We'll do this when we do the history, but they come up with zero, a placeholder for nothing, which we need. And then once you have nothing and you have commerce, yes, it seems intuitive to go this way, and then eventually Pandora's box has already been opened, but then you have the zero. Once I have that, we call this an additive inverse, or in general an inverse. Once I have a 1, is there a guy that when I add it to 1, I get nothing? And that's how you get straight with the bank, which in theory I've got fucking down in practice. So this is why I'm doing YouTube, because the bank wants money. And so the next one we're going to get is, now that I have these numbers, as long as we don't divide by 0, we'll prove it next time. So you can't have, what if we have fractions? And what are these guys? So that's exactly what we're going to get. Q, or quotients of integers, is going to be exactly, and now I'll sneak in quickly before we do it by, we'll do it by rote before we do it rigorously. This is going to be set builder notation. This is going to be x such that, that's what that means, x is equal to a over b, where a and b are integers. And then because I did that, I need to say that one restriction, b isn't 0. And instead of just creating pigeons on a stool and saying you can't divide by 0, I'm going to prove mathematically why you can't. If you can divide by 0 and 0 has a multiplicative inverse, then every number equals every other number, and then math won't work out very well. So no bueno. Don't make Mark mad. Don't divide by 0. This is the quotients, or irrationals. It changes name. Ration. It changes name from quotients. I'll get it right eventually. Two rationals because of the next guy, and they didn't even create a new symbol. You'd think irrationals would be a capital I. No, it's the complement, which we'll get to, of the rationals in there. This is the negation of this guy, x that is not a over b for any a and b in z. Numbers that can't be written as the ratio of integers. And how are you going to, you think we just came up with these numbers to mess with first year calculus students? No. What's happening here is geometry, which they've completely been annihilating from your curriculum over the last 20 or 30 years. But if I take a square, a unit square, and I look at a diagonal, this is, or what you would call the hypotenuse in a right triangle, and I have a leg and a leg, that leg and the hypotenuse in Greek and all the other languages back then, 3,000 years ago, would say that the hypotenuse or the diagonal in a unit square is incommensurable to either of its legs or its sides, which is the same side. So h is incommensurable to a. What does that mean? H is equal to a root, or root 2a, it turns out. And so this guy, Hypatia showed, was in fact an irrational number, a number that cannot be written as the ratio of two integers. So they do exist, and then they threw them overboard and killed 10 oxen, and we're like, we don't like that. Pythagoras thought all numbers were going to be this, and then we figured out there were numbers like root 2, but from geometry considerations, who's another one? There's one from a circle. That C, the outside, to a D, the ratio of C to D is always equal to one number, and he's pi, and he's not the ratio of any two integers. He's the ratio of circumference to diameter, but he's not. The circumference in any circle is incommensurable to its diagonal. You cannot lay off a unit amount. Any unit you use, there will never be one. And this is the other big epiphany why I keep talking about it. And then the favorite one is the golden rectangle, and what the extreme and mean ratio is what Euclid called it. But can you take any segment and cut it in one cut so that the whole length to the larger segment is equal in ratio to the smaller segment to the minimum segment? And this is what we call the golden ratio, phi, not phi, which is 1 plus root 5 over 2, which is also irrational. But do you see my point here? These irrational numbers are not being cooked up to fuck with you. They're being cooked up because in geometric considerations, when they're trying to build the pyramids from these things, they need to know whether they can lay off a unit. And they're like, oh, well, that's never going to happen. You're going to have to throw in a half a block or a 0.141592 block in there because I can't lay off exactly 3. That's where we're getting these guys. And then long story short, he's like, your video is long. Just a second. We're going to take all that mumbo jumbo in the next video and give you what we're going to call in the green pill, the real numbers are going to be the disjoint union of rationals. This is disjoint, BT dubs. What that means is, without the dot, is you need an extra statement. R is every real number has, I didn't have to draw 3 when I wanted to. 0.6 is 2/3, or you can be pi. Every number has, I will do it correctly. I've got a thing. Yeah, memorize those. How does your calculator know that? Oh, we're going to talk about these types of things too. But every number is either irrational and has an infinite repeating decimal expansion. That's a 6. Make my 666. What's the point of doing it if you didn't make it look like it? Or you're irrational, and no number can be both rational and irrational. So we have to go through these types of things in the next one because we want to describe what the real numbers and what the different sets are. We need to talk about what a set is, what set builder notation is, what the set with, notice that that's the empty set, not phi. There, number, the set that has no numbers in it, not 0. This is 0. This is the 0 matrix. This is the empty set. This is phi. They look close, but once we start doing this, they're not the same objects. You'll see nowhere near. These two are the similarist. Similarist? Yes. What I just did there with the English language is what you're usually doing with the math. So we need to talk we need to talk about what sets are, what set builder notation is, how to build complicated sets of numbers that we're going to talk about, who the set with nothing in it. Why do I need a set with nothing? Because when you take an intersection or try to create a new type of set and there's nothing in common, you've created the set that has nothing in it. And then we need union. And long story short, every real number has an either infinite repeating decimal expansion, 2/3, or pi, infinite non-repeating, and you can't have a number which has a repeating and non-repeating at the same time. The real numbers are the disjoint union of the rationals and the irrationals in the green method. Yes, they are the unique field which satisfies 14 axioms after we create equivalence class of Cauchy sequences or Dedekind cuts. See you next time, I hope. Please come back. Subscribe and bullshit fucking there. Then the next thing that we will do in this class is we will start talking about